After we looked at the difference of two squares, you might think the sum of two squares works similarly. Unfortunately, it doesn't. As it turns out, the sum of two squares is impossible to factor. We say that this is prime. Like a prime number, that means you can't factor it. You can't write it as a number of factors. So the sum of squares is always prime, which means it cannot be factored. So remember, if you see a minus, you can factor that. If you see a minus, a squared minus b squared, that factors into a plus b times a minus b. But if you see a squared plus b squared, that is prime. So make sure you can tell the difference there, because that is very important. So for example 1 is a problem that is prime, because there is nothing you can do there. You can take the square roots of both parts, but the thing is you cannot actually write that in a way that is factored. You might think that you could write it as x plus 3 squared, but if you FOIL that out, you'll actually get x squared plus 6x plus 9, which isn't what we're looking for. That is prime, which means you can go no further with it. But you have to be careful. That doesn't get you off the hook entirely. If there is a GCF, you still need to factor it out. For instance, with example 2 here, we could factor 2 out of both terms, because they're both even numbers, and we could factor b out as well, whereupon we get 16a squared plus 25b squared. We can't factor that any further now, but the fact that we can still take out a GCF is significant. So remember, the difference of two squares can be factored, the sum of two squares can't.